In this video, we'll talk about solving some pretty simple logarithmic equations. So here we have log of 3x minus 8 equals 1. Now something to recognize here is that this is talking about a common log. So we have a base 10 that isn't shown here, but we know that it's base 10 because we know if there's not a base shown, then that means that it's the common log of base 10. So if we do the loop trick, right, the loop trick is really useful. Okay, it'll tell us that 10 to the first power is equal to 3x minus 8. Well, 10 to the first power is just 10, so we just need to solve this for x. So we'll have 3x equals 18, or x equals 6. So the answer to this one is just 6. Here we have another one, 400 equals 50 times the log of 10x. Now, just like with anything, we should probably see if we can simplify this first. So we're going to divide everything by 50 first. And when we do that, we'll end up with 8 equals log of 10x. Okay, again, we have to recognize that this is talking about a common log because there's no base shown. That means it's base 10. So if we do the loop trick for this one, okay, remember we always go in the direction of the equal sign, we'll get that this is 10 to the 8th power is equal to 10x. And so this might not be obvious how to solve this one, but what we can observe here is that 10 to the 8th is equal to 10 to the 1st times 10 to the 7th, and that equals 10x. And if we divided all of this by 10, that this 10 and this 10 would cancel. And you can then see, oh, and obviously that one. So what we would get then is that x is equal to 10 to the 7th power, or whatever that is, 10 million, right? Right, here's one that uses natural log, and notice the argument, the variables in the argument of the logarithm. So what we should do is kind of get everything else on one side of the equation. So first thing we should do is subtract 4 both sides. So if we subtract 4 from both sides, we'll have negative 6 equals negative 6 times the ln of 3y. Then we can divide both sides by negative 6, and we'll have 1 equals the ln of 3y. Okay, now, natural log, that has a base of e, right? It's a logarithm of the base of e. So we can do the loop trick, and we can say that e to the first power is equal to 3y, and we're just solving for y here, so we just divide both sides by 3. Y will equal e divided by 3, or 1/3 e, same thing. And that's a totally fine answer to have. E is just a number, right? We can even use our calculator to get it. Just type in e instead of what it approximates to, which is 2.81, 2.817, 2.71828, right? Yeah. Okay, so that's how you solve that one. Here's one more problem. Okay, log of x squared equals 12 minus log x. Now this one here is drastically different from the other ones. And it might seem like we can't really solve this, because how do you combine those two x's, right? We haven't talked about that yet. And so as is the case sometimes with math though, if we see something complicated, maybe there's something we can do to make it less complicated. And in this case, what that thing is going to be just substitution. So I'm going to say, I'm going to let a equal the log of x, okay? And so what that lets me do for now, right, I might have to keep that in mind because I'll have to go back and revert that later, but this is a squared equals 12 minus a. Now this still might not be clear, but if we rearrange this to say that this is a squared minus a squared plus a minus 12 equals 0, well, now we see clearly that this is a logarithm. And I could totally factor this logarithm too. I could say that this is a plus 4 and a minus 3 equals 0. So I have two statements then, and that's that a could equal negative 4 and that a could equal positive 3. Now that's the zero product property I applied there. And so I'm not done, right? Because I have to remember that we said a equal to the log of x. So if the log, I didn't know how to write, sorry. If the log of x is equal to 4, sorry, negative 4, this would be negative 4, right? Negative 4. Then this is saying, right, because we have the base of 10, if we do the loop trick there, that's saying that x is equal to 10 to the negative 4th power, which is the same thing as 1 over 10,000. We could also say, because this one here says that the log of x is equal to 3, this means that x is equal to 10 to the 3rd power, which is 1,000. So the answers to this one are x is equal to 1 over 10,000, and also it's 1,000. So we have two answers to the same question, which makes sense because I have this exponent of 2. It's like I'm dealing with a polynomial here, and if the highest degree of the polynomial is 2, the fundamental theorem of algebra says we should have two answers. So that's actually a fairly difficult logarithm problem to kind of wrap your head around there, but in any case, we're putting into practice the concepts of natural log and common log. These are far from the most difficult or complicated type of logarithm equations that we deal with. But in any case, I think they're useful ones to see because they do show up. These kinds of ones show up fairly often.